Alrighty guys, let's take a look at this IXL. The title is Similar Triangles and Similarity Transformations. Let's read our first problem here. It says you can transform triangle QRS to triangle Q prime, R prime, S prime by translating it and then performing a dilation centered at the origin. So triangle QRS is similar to triangle Q prime, R prime, S prime. That's one of our definitions of similarity. If you can, if one is a transformation of the other. Find the translation rule and the scale factor of the dilation. This is very similar to our similarity of circles IXL from last week. We are going to be mapping one figure to the other using a translation rule that you guys are going to define. And then we're going to be determining the scale factor, and you're going to be putting those answers down here at the bottom. So this is really a two-part problem. Okay, first thing they want us to do is to write the translation rule. This is a little different than circles. With circles, we were mapping from the center of one circle to the center of the other. With this, we're mapping from one point on the triangle to a point on the other, and it's important that you select the correct point. So what point are we going to use? We're going to look at the origin, we're going to look at the center of the coordinate plane, and we're going to see what point is there, and that is the point that we are going to map, okay? So we can see that Q prime is at the center. That means we are going to be mapping the Q's for this one. So we're going to be mapping from Q, regular Q, pre-image Q, to Q prime. Okay, and we need to figure out how left or how far to the left and right, how many blocks to the left or right, and then how many blocks up to reach our final destination. So we're starting at Q and we're ending at Q prime. All right, we're going to go to the right or the left until we get to the grid line that Q prime is lying on. So it looks like we need to go to the left just a little bit, just one block to the left. Okay. So we're going to the left, one, to the left, one, and then we need to go up on this grid line until we reach our final destination. So we're going to go all the way up here, and we're going to count those blocks. So this is 1, 2, 3, 4, and 5. So we're going up 5. Need to take these directions to the left 1 and up 5, and we need to write them in our XY notation. Let's do a little review of what that notation is. Okay, so to the left and to the right, that's the X direction. So if we go to the left, we're going to be writing X minus whatever number, however many blocks. And for us today, that was 1 block. We'll fill that in a moment. If we happen to have been going to the right, it would still be X, but it would be X plus. Okay, because the positive numbers are to the right on the number line. If we were going down, the up and down variable is the Y variable. Down is Y minus. And if we were going up, which we're going to use this one, we would do Y plus. Okay, so that's how we write out the directions. Let's go ahead and do that. So to the left 1, that's going to be X minus 1 is going to go right here. And then up 5, let's go see what up was. Up is Y plus. So Y plus 5. So that's our translation rule. And then we need to find the scale factor. And if you guys recall from the circles lesson, I made a big deal about saying that the translation rule and the scale factor are two completely different problems. And yeah, it's the same thing again. So we're not going to use the 1 and the 5 necessarily for the scale factor. There could be a 1 and a 5 in it. I don't know. I didn't figure it out yet. But if there were, that would just be a coincidence. So this is an entirely new problem. And what we want to do is we want to make our fraction, let's take our notepad out again. Okay, so the scale factor is equal to, we say it's prime over not prime. What does that mean? We are going to find the length of one of the lengths of the sides of the triangle with the prime symbol. So I think I'm going to do R prime S prime. That's going to be my prime length. And then we're going to find the length of the corresponding side on the triangle that does not have the prime symbol. So this guy right here, RS. Okay, so it's going to be R prime S prime over RS. So let's go figure out how long or how long our S is. So I'm sorry, R prime, S prime. So from R prime to S prime, that's from -9 to +6, and 9 plus 6 is 15. So I'm using a different method for figuring out the length here. And I use this method whenever my points are really far apart. I really don't trust myself to count out those blocks. So I'm looking at where I'm at. I'm at -9 and I'm at +6. One's a negative and one's a positive. So we're going to add their absolute values. 9 plus 6 is 15. And then I'm going to do R to S. For R to S, I can actually just count these out. I think this is pretty easy to count. So 1, 2, 3, 4, and 5. Okay, my prime length is the 15, so prime over not prime. Okay, and so our scale factor is going to be 15 over 5. We want to simplify that though. If you are not feeling super confident about simplifying, you can go over to your Desmos calculator. The link for this is in the checklist, and you can just put this number in. So 15 over 5, and that's going to simplify to 3. If it were to simplify to a fraction, there would be a little button right here, like a little circular button that you could click on to show the simplified fraction. R simplifies to a whole number though, so our scale factor is 3. Okay, and that makes sense, right? The pre-image is the green and the image is the purple, and it does look like it got 3 times as big. So let's go ahead and submit, and we'll do another one. Okay, so let's try this one. Okay, so same directions. It says you can transform triangle QRS to triangle Q prime R prime S prime by translating it and then performing a dilation centered at the origin. So triangle QRS is similar to triangle Q prime R prime S prime. Find the translation rule and the scale factor of the dilation. Okay, so where do we start? Well, we start by looking at the origin and looking at what letter we see at the origin. We see Q prime, so that tells us that we are going to be mapping the Q's. So we're going to go from Q over till we get on the same grid line as Q prime, and then we're going to go down until we get to Q prime, and then we're going to write out these directions with using our XY notation. Okay, so to get from Q over to the grid line, we went to the right. Let's see, we'll write that out here. So we went to the right. Okay, how far to the right did we go? We went 1, 2, 3, 4, 5 to the right. Okay, going to the right, that's the XY direction. And look, they kind of give you a little hint here that the first letter is going to be an X and the second one is a Y. And then let's pull up our notes. To the right is X plus. Okay, so X plus 5 because we went 5 to the right. And then we went down. So from here to here, that's going down. And let's count how many blocks down. So 1, 2, 3, and 4. Down 4, let's look at our notes. Down is Y minus, so that's going to be Y minus 4. Okay, on to scale factor. Brand new problem. Let's get rid of all this stuff. All new problem. And we want, again, let's look at our notes for scale factor, prime over not prime. Okay, so prime. So I like R prime, S prime because it's sitting nicely on the grid line. So let's figure out what this length is right here. They're pretty far apart, so I'm going to use that other strategy where I look at where they fall on the x-axis. So R prime is at -4, S prime is at +8. One's a negative, one's a positive, so we're going to add them together. 4 and 8 is 12. You could also count the blocks. And then RS, I'll just count for this one. It's nice and short. 1, 2, and 3 blocks. Okay, prime over not prime, 12 over 3. Pop over to our Desmos calculator, and let's do 12 over 3, and that's equal to 4. And we're going to submit. Okay, cool. Let's do one more. I think I have enough time on this video to do this last one. I'm gonna talk a little quicker though. I'm not gonna read the directions. I want to do this one because I'm already seeing that the scale factor is going to be a little bit tricky because we don't have any sides laying straight on the grid lines. Okay, so we're going to look at the origin and we see that we have C prime at the origin. That means we're mapping letter C. So let's go up here to C and we are going to go, whoops, where's my pen? Here it is. We're going to go all the way over to the left until we get on the same grid line as C prime. And then we are going to go all the way down. Okay. How far to the left did we go? Well, we started at 8 and we went all the way to 0. So we went to the left 8. We went to the left 8. Pull up our notes. Left is x minus, so x minus 8. Okay, then we go down. So from here, we went down and we went down from 5, this is 5 right here, all the way to 0. So we went down 5. Sorry about my handwriting. I cannot write with this tool very well. Hopefully you guys can see that. Down 5, y minus, so y minus 5, okay? And then let's get rid of all this stuff. Scale factor is going to be a new problem. And since none of them are laying flat on the grid lines, I'm going to choose a pair of sides that are sort of kind of laying flat, okay, that are pretty close to flat. Like B prime C prime to me is like almost laying on this grid line, but not quite. And this is what we're going to do. Okay, so it would be nice if we could just like measure this diagonal. That's a little bit tricky at this point in this course. Actually, it's a little tricky no matter where we are in the course. But wouldn't it be cool if we could pull B down to where C is sitting, pull it down to that grid line right there, to the x-axis, and measure this? And it turns out that we can. Okay, so let's just measure this distance right here. We're measuring the horizontal distance between B prime and C prime. So how many squares is that? It's 1, or how many blocks? 2, 3, 4, and 5. Okay, so we're going to use 5 for B prime, C prime. If we use B prime, C prime, we have to use BC, right? We have to use corresponding sides. Same thing, it would be really, really cool if we could measure this, but it's a diagonal. So since we can't do that, let's pull B down to the grid line that C is sitting on, and let's count here, okay? Or we could use the numbers down below. I think I might do that. So this is 8, and this is -2. One's a positive, one's a negative, so we're going to add them together. 8 and 2 is 10, or you could count those blocks. Okay, now prime over not prime. Prime is B prime, C prime, so that's 5. Not prime is BC, so that's 10. And then we need to hop over and we need to simplify this. Okay, so this is good. This will be a good example of one that's going to turn out as a fraction instead of a whole number. So 5/10, it says it's equal to 0.5, but we want to express it in terms of a simplified fraction. So click on this little circle right here, and it will change it to 1/2 for you. So our scale factor is 1/2. Let's submit. Hopefully we don't have any mistakes. Cool. All right, guys, good luck on this one.